I will start this video with one example. I will create a custom function, and inside of this function, I will first declare a table. I will insert a value inside of that table, and I will return that table. Next, I will test this function inside of a select statement, and the result will be our declared table. Now, this declared table is actually a table variable, and table variable is temporary in memory structure, and this table variable will only exist during the execution of a function. The main purpose of table variables is to build up a result set that will be returned by a function, and they can also be used to store interim results for procedural logic. Table variables are mutable. That means that all data manipulation statements will work on them, so we can use insert into, update, or delete. It is also possible to create a table variable that is based on a real table by using as select statement. And for that, I will first create one sample table with this statement here. I will insert the value inside of this sample table, and we can read from this table to see how it looks like. And now that we have our sample table, we can create a new table variable based on that table. So this will be it. I will create this table variable that is based on this sample table, and we will add this subclause with data. So I will run this, and after this we can read from this function, and we will get our table but without data. So although I use this subclause with data, when we are using select for table variable, we will never inherit any data, but we have to use insert into, just like in this previous example. I will now clear my screen. I must tell you about two limitations of table variables. I will paste here one example, and this is a custom function definition. Inside of it, we have table variable. But this table variable is using primary key constraint, and this is not allowed. So if we run this statement, we will see that constraints are not supported on table variables. Next, I will paste another example here. Again, I will paste the statement that is used to define a custom function. Inside of it, we will create table variable, but after that, we will try to alter that table by using alter table statement. We will try to rename a column, and if we run this, we will get an error message because it is not possible to alter table variables. I will now clear my screen. Beside table variables, it is also possible to declare and set scalar variable. Here I have one example of that. I will first declare scalar variable with the name var1 that is of integer data type. Scalar variables are mutable. That means that we can assign them one value, and then afterwards we can assign them some other value. I will create this function, and then we can use this function inside of a select statement, and the result of this select statement will be 88 because that is the last value that was assigned to our scalar variable. Now in this example, I have declared only one variable inside of one statement, but it is also possible to declare several variables inside of a declare statement. So I will show you that in this example. Here I'm declaring one integer variable and one char variable inside of one declare statement. Everything else is the same. So if I run this, this will also work. So if we now read from our function, and this function will now return a table, we will get this result. And at the end, I want to show you that it is also possible to set both variables in one statement. Here I have first set variable 1 and then variable 2, but in this next example, we can use select into statement to assign these two values to these two variables. So if I run this, I will get the same result as previously, but this time we have set our values in one statement instead of two. I will now clear my screen. We can assign a value that is the result of some expression to scalar variable. So here I have an expression 32 plus 5, and I will assign the result of this expression to my variable. So when we read from this function, we will get the result 37. It is also possible to use select statement instead of these simple expressions. So I will show you this other example, and this time our select statement will return one number, and that number will be assigned to variable 1. And we can use variable 1 to assign a value to variable 2. So variable 1 will be 32, and then we will have 32 plus 5. So again, like previously, if we now read from our function, the result will be 37. Instead of this previous statement, we can use a shorter syntax like this one, where we are going to get one value with select statement, and then we will directly add number 5 to that value. So this is also valid. So when I read now from our function, again I will get the value 37, which is 32 plus 5. At the end, I want to show that it is possible to do multiple assignment with select statement. So in this example here, I have a select statement that will return number 32 two times. So we have one row with 2 columns. And we can assign both of those values to our variables, and the result will be division of those variables. So when we now read from our function, we will get the value 1, which is actually 32 divided with 32, so the result will be 1. I will now clean my screen. Let us talk about usage of scalar variables. Here is one example that will show us that we can use variables everywhere where we can use constants. So I have this variable here, and I can use it inside of a where statement. So if I run this, this will be successful, and we can see that our function is working correct. But we cannot use variable instead of identifier. So I will show you that in this next example. Here I will declare a variable, and I will assign a value n to that variable. And then I will create one table variable, and this table variable will have a column with the name var1. And this var1 is literal var1. It is not 10. So this is not considered as a result of a variable, but as a literal string. So when we try to read from the column n, we would get an error because that column is unknown. At the end, I want to show what will happen if we declare a variable, but we do not assign a value to it. So I will declare a variable, but I will not use a set statement. So I will run this. This is successful. But if we now try to read from this function, we will get null, because each variable has a value of null in the beginning. I will now clean my screen. Let us now talk about case statement. Case statement is used to control logic flow in procedural SQL. I will now jump here to this web page, and we will take a look at how witness thinks when he is faced with the police lineup. Witness will scan faces of the people in the police lineup from the left side to the right side until he finds a person that matches his memory. And then he will declare that person a culprit. And this is the same how case statement works. Case statement will evaluate a sequence of the conditions until it finds a condition that returns true. And then the case statement will return a value that is associated with that condition. Let us now go back here to terminal, and I will show you an example of the case statement. Inside of this case statement, we can see that we have pairs of when and then substatements. When is used to define a condition, and then is used to define the result if that condition is true. And the result has to be the full statement, so we cannot return an integer or a string. We have to return a statement. And if none of these conditions in the list is met, then we will return a statement that is after the else keyword. I will now run this, and then we can try our function. So if the argument is 1, then we should get an A. If the argument is 2, then the second condition will be true, so we will get a B. And for all other values, we should get C. For example, if argument is 99, we would get C. Now, sometimes it is possible for several conditions to be correct at the same time. Let's look at this example. If our argument is number 2, then this condition will be true because 2 is smaller than 3, but 2 is also smaller than 5. So this second condition will be true also. So in this case, this first condition will be a winner. And the reason is because this condition is closer to the top of the case statement. So when we start evaluating our conditions, we will first evaluate this condition and we will immediately get our result. So this second condition will not be evaluated at all. If we now run this, and if we try our function with the argument that has the value 2, we would get the result A, because this first condition will be a winner. I will now clean my screen. If all of the conditions in our case statements are equality based, then we can use this simpler syntax. Here we are comparing the value of argument with the value 1 and with the value 2. So this condition here is the same as when argument is equal to 1, and this is like when argument is equal to 2. If we need some other logic to define our condition, then we cannot use this shorter syntax. I will run this, and then we can try this function with the value of argument that is 2, and we will get the value B. Next, I want to show you that it is possible to nest case statements. So here I have one other example, and here is the case statement that starts here and ends here. But inside of it, we have another case statement, so it is possible to nest them. You should notice that in both of these case statements, we don't have else substatement. So else substatement is not mandatory and we do not have to use it. But what will happen now if we run this function with a value of argument that will not met any of these conditions? So this condition here will not be met, and this condition here will not be met, and we do not have else substatement. Well, in that case, the result will be null.